Hello, my name is Leila Sanchez and welcome to my final project submission for GPE205. I would first like to start by saying that my game contains a game manager that is a singleton. The singleton pattern is a design pattern used to ensure that a class has only one instance and provides a global point of access to that instance. Here on line 11, I set the game manager to hold an instance that I will use later to ensure that only one instance exists at a time. On the awake function here on line 65, this is where I say if the instance does not exist yet, make this the instance and don't destroy on load. Otherwise, there already is an instance, so we want to destroy this game object. My game manager also contains a FSM or finite state machine that controls the game state. My FSM starts down here on line 416. Alright, and this is the start of it with the helper functions and the different states that can be active. And this goes until 582 so far. Right here. The game manager keeps an up-to-date list that records the players visible up on line 32. And that is right here. And this list is populated on the player controller script. Let's take a look at that. Here on the start function, if the game manager is not null, we will add this as a player to the list on the game manager script right here. I also keep track of the possible pawn spawn points that get loaded in after the gameplay state is selected. And I believe that is going to be on line 348. Right here. I also used Unity Engine's random range to choose a spawn for the player every time. Moving on, I utilized the pawn controller pattern with inheritance to create the game. Starting with the controller script, we have our public start function, and our important public abstract process inputs that is going to be overridden in the player controller script and as well as all other controller scripts. But using the process inputs is how I define how the player is going to move using the get key. And this defines how the player will move its pawn by updating the process input function that was inherited from the controller script. For the pawn controller pattern is when we have the player controller handling input and delegating actions to the player pawn. Let's take a look at the pawn script now. This is my pawn superclass where most important variables are stored for easy manipulation. And down here, I override all these functions in my tank pawn script that inherits directly from the pawn script. And this is the inheritance. OOP, or Object-Oriented Programming, is a principle that allows a subclass to inherit attributes and behaviors from an existing class called a superclass or base class. Another use of inheritance in my game is with the power-up site implemented. Let's take a look at those. Starting with the power-up script itself, it doesn't derive from mono behavior because it will not be directly assigned to a game object, nor is it a component. And let's take a look at a power-up, for example, the extra life power-up. And you'll see that it inherits from the power-up class and it overrides the apply and remove functions. My AIs and players use the same pawn code and core components like health, for example. Looking at my AI controller script, you'll see that it inherits from the same controller script and overrides the process inputs function with a FSM. Utilizing the component pattern in Unity allows the code to be modular and reusable, easily extended, and take advantage of the inheritance pattern like this. Back to the Power-Up Manager script. I used a timer that takes a predefined duration as input and determines when to remove the power-up if it is not marked permanent. And this is on lines 51 through 68. I also used a timer to limit the number of shots per second fired on the tank pawn script. And that is limited. And on the shoot function, on line 144 ensures that the shooter can only fire at a certain speed defined by the timer delay variable. This timer is based on the difference between the current time, represented by time.time, and the variable next event time. Moving on, I have also created a start and game over screen that I will show in the editor here. All right, this is the title screen I've got. And then from here, it'll take you to the main menu. And to show the game over screen, you have a choice to either exit out to the desktop or return back to the main menu to try again. Let's take a closer look at the buttons. Here in the inspector of the button, we can see the rect transform component that defines the size and position of the UI component within the canvas, which is this rectangle. Anchors are going to define how a UI element is attached to its parent or canvas. This can be set to the left, for example, and then all changes will have the left representative of the center. Pivot is the point around which a UI element rotates or scales. For my project, I use the center of the canvas as my anchor and pivot point. And let's jump back to the game manager script now. On my spawn player 1 function, right here, I manipulated the camera code to have it follow the player, and that's lines 197 through 199. And I did the same for the spawn player 2 function since they have their own separate camera. Moving on, the AI in my game can seek, flee, and patrol. They also utilize hearing and vision conditions depending on the AI personality. Let's take a look at the scripts I have for that. I have my base/superclass for my AI controller, and then the child personalities inheriting from the AI controller script. I will also be demoing the AI later on, so stay tuned for that. I did use sound tools at some points in my game. One notable mention would be on death or when the player loses a life. Let's take a look at the health script. Here I run a function called explosion effects, and that is defined on line 66 here, that will play a particle effect and explosion audio at the position of the game object the health component is attached to. Continuing on, let's take a closer look at the tank pond script to get a sense of how I utilize time.delta time. I used it first in combination with my noisemaker to make it a gradual sound decrease rather than an instant one after stopping moving here on line 55. And then also on the rotate towards vector 3 target position function on line 157. Maybe not 157. right here, 150. And here I used the time.delta time to limit our turn speed allowed per frame. On the tank shooter script, I used rigid body. Get that open. And I used rigidbody.add force to make the bullet appear to fire from the fire point defined on the tank pawn's prefab. My game also uses rigidbody.move position on the tank mover script, and that is here. Rigidbody.move position. And here I define the move function and call to the rigid body function move position to define the vector for the rigid body object this component is on to travel down. I also use transform.rotate to define how the pawn will rotate here on line 27. Besides this, my game also uses input.getKey most predominantly on the player controller script to define the process inputs function. Let's get that open. And on top of the script, I made all the key codes public so that way they would be exposed for designers to put their own. And I also use the input.getKeyDown on this same script right here on line 85 to check if the player is shooting, and if so, make noise. I also check to see if any of the defined input keys are down, and if they are all up, the pawn will stop making noise, and that's on line 93 right here. Back to my game manager. My game manager does instantiate prefabs and destroys game objects once health or time conditions are met, and this will be demoed when I play the game later. So for now, let's take a quick look at my damage on hit script to show a for loop. Alright, here on line 43 is the start of my for loop. It works by first initializing the variable I equal to 0, and this variable represents the index of the current element in the colliders array defined up on line 40 right here. The loop condition is as long as I is as long as the value of I is less than the length of the colliders in the array, we are going to continue. And the exit condition or iteration expression is I++. That is going to add 1 to I after each iteration. I have an if statement within the for loop for condition checking the loop to determine whether the pawn component of the current collider is not equal to the owner of the fired projectile. All right, with all that out of the way, now let's take a little demo of the game. Right, so once we start up, we are going to load into the title screen and click anywhere to start the game. So I just stretched out the button to fill the whole display. And once you do that, we can select play game, quick game, options, or credits, and it'll take us to the corresponding page. So let's go for play game. Not sure why it looks so strange. Try that again. Hit play, click play game, and there we go. You control the one on the left with WASD and space to shoot, and the one on the right with the arrow keys and enter to shoot. And let me pause this real quick. I'm going to pull up the thing right here. And this is our guy getting shot right now. But I wanted to show my respawn feature I have. And so we'll keep an eye out for the current health and the current lives right here. Make sure I don't pick up a power up there. Awesome. And then once you die, you come back with 100% health and you respawn in a new location. Alright. He's controlling. Power-ups. Little speed boost there. All right, and that just about does it. Thank you.